what we're looking at today is, it's actually a new lesson. This is a Unit 11 lesson in the textbook, but we're not in the textbook at the moment. Solving absolute value inequalities. Absolute value inequalities. Now, what I want you to do to kind of get you thinking in the right way about this skill is I want you to draw a number line. Just put 0 in the middle. That's yesterday's coffee. Fail. All right. Yesterday's coffee's not still fresh, even in the Yeti.
Yesterday's coffee.
It's in that cup right there.
How did you drink that coffee?
Well, I just picked up the wrong cup. Give me a break, Ray.
Gosh, Greg.
I don't have a spinner that's keeping me focused, or 6 pieces of gum that I'm chomping on so loudly that the entire class can hear. Please discard that in the garbage can. You'll have to be a little bit more discreet with your gum. Look at this wad of gum. Everybody show it. There is not a scale in the chemistry lab that could weigh that massive piece of gum. All right. That's Gray DePriest, ladies and gentlemen, YouTubers. All right. All right, here's what I want you to do. Are y'all ready? Are y'all ready?
Yes.
I want you to, on your number line, shade all numbers. Are you listening? Shade all numbers whose distance from 0 is more than 5. I want you to shade all numbers whose distance from 0 is more than 5. More than 5. No, I want you to think about this. I want you to struggle with it for just a moment. All numbers whose distance from 0 is more than 5. Y'all can give me an example of a number whose distance from 0 is more than 5, can't you? Negative 6 works. 6 works. Negative what?
I said 83.9.
83.9 is definitely more than 5 units from 0. All right? But I want you to shade, that's part of it, but that's only part of it, right? What about the ones over here whose distance from 0 is more than 5? Yes, I'm seeing some good things. Hey, don't over-label your number line. Don't over-label your number line because that takes too much time. Okay? I'm seeing some good stuff. Should you have a closed circle there? If the distance just has to be more than 5? Okay. So if we're talking about whether our distance from 0 is more than 5, it can't be equal to 5, right? It has to be more than 5. So how would we show that it's more than 5? Now, most of you guys have this correct. All right? All right? Now, a few of you are close, but not perfect. Why can we not start at 6?
Because that missed out on things like 5.5.
Yeah, we miss all the numbers that are bigger than 5, 5.1, 5.2, 5.3. Those numbers are also part of it, right?
So if we had 5 with an open circle, that would work.
Yes, so the way this works is, if we're going a distance greater than 5, we would go this way, or we would go this way. And probably more than 75% of you got that right. That's all numbers whose distance from 0 is more than 5. Now, why are we talking about distance today? Because absolute value is distance. Okay? Now, good? Does everybody see why that's the correct answer? All right, let's do, similarly, draw another number line. I want you to shade all numbers whose distance is less than or equal to 7. And by distance there, I mean distance from 0 is less than or equal to 7. We want our distance from 0 to be less than or equal to 7. You just need 0 in the middle, and all right, because we're just talking about the distance from 0. Looks good, Tatco. We want our distance to be less than or equal to 7. Shade all numbers whose distance is less than or equal to 0. Distance from 0 is less than or equal to 7, excuse me. Okay? Chase, describe what you've got.
Close circle at 7, shade to the left, and a close circle at -7, shade to the right.
So, do we go past -7 to the left? So, we got a closed circle here and a closed circle there because our distance can equal 7. And then all the numbers whose distance is less than or equal to 7, that's all the values in between there. Does that make sense? Okay, so when we're approaching our absolute value inequalities, we're always talking about a distance being greater than or a distance being less than something. Now, what does this look like? Does this look like an and problem or an or problem? It looks like an and problem, right? Because what two inequalities are we satisfying in this particular one? Chase just said it perfectly. It's less than or equal to 7 and greater than or equal to -7. He said it perfectly. All right? What about the previous example? The previous example we graphed, did that look like a... It's going to take me a second to get that. Look like an and problem or an or problem? It looked like an or problem, right? Because we're opening out. So what would the two inequalities be here? X is less than -5 or X is greater than +5. So if we're dealing with absolute value inequalities, our distance is either going to be more than something or our distance is going to be less than something. Y'all listen. If the distance is more than something, we're opening to the outsides like this one, we have ourselves an or problem. If our distance is less than something, like we just did the distance is less than 5, that closes in, that gives us an and problem, right? We're going to have intersection or crossover. So as a rule, an absolute value inequality, if its absolute value is greater, it's or. If the absolute value is less, it's going to split into an and problem. All right? Now, fantastic job with that. Let's go to an example. Now, the only things that I want you to see in this problem, guys, is the absolute value symbol and the greater than symbol. Because we have, how many things do we have in this problem? How many things are on the left side? One thing on the left side. Right? And how many things are on the right side? One thing on the right side. Okay? And what do we know about the thing on the left? What is this absolute value? Somebody read this as using the definition of absolute value. The distance from 0 of x plus 2 is more than 5, right? The distance from 0 is more than 5. This means it can be greater than 5 or less than -5. So when we split this, that's exactly what we're going to do. We're going to split this into two inequalities. X plus 2 in this instance has to be greater than 5, or x plus 2 has to be less than -5. Because our distance from 0 is more than 5. That means it's got to be to the right of +5 or to the left of -5. All right? So how could you kind of describe this process? What did we do?
Subtract 2.
No, not moving forward. How could we describe what we've done from our original step to these two steps? I've written it the same way, right? This is written exactly like this one. What did I do here?
Change
flip the symbol and change the sign. That's going to be the process both times. But the important thing, what's the important part of this compound inequality? The word or. Or, because that tells us the relationship between the two inequalities. From here, it's really easy to solve, easier than any of the stuff you did for homework last night. What would we do? Subtract 2, and on the right we get x is greater than 3. And on the left we get x is less than negative 7. Okay? So what would that look like on our number line? How do you graph an OR problem? Union. You just graph them together. That's right. So negative 7, positive 3. Open circle at negative 7 and shade to the left. And then greater than 3 is an open circle and shade to the right. All right? Very good. Are we done? Now I want you to express your answers as also in interval notation, right? So how would you write the left side of this graph in interval notation? Parentheses. Robert, let me hear you. Parentheses. Negative infinity. Negative 7. Parentheses because it's an open circle. And or, I think I showed you guys this yesterday. That's the union symbol. Or you could write the word or, you can write the union symbol. What would the other interval be? 3, comma, positive infinity. Infinities always get parentheses. Yes, Chase?
If that was an and problem, would it be parentheses negative 7, comma, 3 parentheses?
Yeah, if we shaded in between those, it would just be negative 7, comma, negative 3, positive 3, parentheses on the outsides because of the open circles. All right? It's easy enough, right? You got to remember what we're dealing with here is a distance problem. Okay? So let's have a look at the next one. And here's a little kind of acrostic that can help you remember this if you have any trouble with it. Go to LA. Right? Greater is or, less than is and. Okay, I just kind of like people to remember greater is or. Greater or. I know it's supposed to be greater, but greater is or. Less than and. Okay, only when you're dealing with what? Absolute values. Our regular inequalities, we're not going to split them into two. We're going to keep them as regular compound inequalities, or regular inequalities. All right, let's go to next example. All right, x minus 2 in absolute value is less than 6. This is less than. And like we did in our kind of that warm-up exercise that we did, if our distance from 0 is less than 6, that's closing into 0, right? From 6 and less than 6. So that's what kind of problem? And or? And, right? Less than and, greater or. So if it's an absolute value, less than is always going to split into an and problem. So we're going to write it as it is. This means that x minus 2 has to be less than 6, and x minus 2 is greater than negative 6. Very good. Flip the symbol, change the sign every time on the absolute value inequalities. Okay? Now when we solve that, on the left we add 2 and we get x is less than 8. On the right, we get x is greater than negative 4. This is an and problem, so what am I looking for? Intersection, right? So I'm going to do negative 4, positive 8. Greater than negative 4 would be what? Open circle and shade to the right. Because we're looking for intersection, we graph and problems above the number line and look for where they cross over. Less than 8 is this, right? So where do they cross over each other? between the two numbers is where our crossover takes place. So that's what my solution is going to look like. These things up top, that's just how I find that solution. So if you're ever graphing this and putting the number line down as your answer, that's the answer. The other parts above the number line is just where we're looking for the answer, looking for crossover. Where interval notation for this interval, Blake, what would the interval notation be?
-4, parentheses, -4.
Good.
To
Where does it stop?
8,
8.
parentheses,
Why is it a parentheses? You weren't sure of yourself.
open circle.
Open circles, parentheses. If there's a closed circle, we put a bracket. Good. It's not too bad, right? All right. Now, just like the absolute value equations, guys, we're going to always need to make sure that our inequalities or the absolute value symbols by itself first. And we'll get to that in just a second. Let me ask this question. Is this an and or an or problem? Or. Greater is or. Greater is or. Greater is or. Less is and. Greater than or less than and. But only when we're dealing with absolute value inequalities. So this is going to split into an or problem. Our distance is greater than 4, right? Our distance is greater than 4. So we want 2x minus, our distance is greater than 8. I keep saying 4 there. Our distance has to be greater than 8 or less than -8. Very good. Less than or equal to -8. So we're flipping the symbol and changing the sign. Then what? Add 4 on both equations, inequalities rather, divide by 2. Some of you guys are learning aggressively today. Some of you are passively learning. Don't be a passive learner. Passive learners barely pass. So passive learning is not really passing. Passive learners are passing the A's and B's by, getting C's, D's, and F's. Don't be a passive learner and pass up the good grades. Be an aggressive learner. Aggressive learners make A's. All right. Add 4 to both sides. We get x is greater than or equal to 6. Add 4 over here. We get x is less than or equal to -2. Right? Divide by 2 in each instance. Now this is an OR problem. OR problems are really easy to graph. We want to just slap them together on the same number line. -2, +6. Be careful. Obey the inequality. X is less than -2. That's shaded to the left. Greater than or equal to 6. We're going to shade to the right. I'm going to show you an OR problem in just a minute, where you've got to pay attention to the direction that you shade, okay? Because we can shade these to the left, in which case we would be filling up the whole number line, right? And our solution would be all real numbers. So we've got to be careful with that scenario. I showed you yesterday, and you'll look at one in just a moment that fits that description to a T. So, sorry, I went a little too far. Oh, really? All right. Now let's think about this. Sorry, Mac, I didn't mean to be sarcastic. Well, a little bit. Let's think about what this interpretation would be. What's different about these problems? Right, there's a negative. Now let me ask you this. Can an absolute value from last night's homework, can an absolute value equation equal a negative number? No, because absolute value has to be positive. But this is something different, right? And let's think about what this is saying. This first equation, or inequality, is saying, hey, our distance, which is what kind of number? Positive number, has to be greater than -8. When is that going to be true? When is something positive going to be bigger than a -8? Always. Anytime something is always true, our solution is all real numbers. How would I graph all real numbers? Shade the whole number line. How would I write it in interval notation? Negative infinity to positive infinity, right? Now, what is this next one telling us?
Nothing
It's
true.
not true.
That our distance from 0, something positive, is less than negative 2. Can a positive value be less than negative 2? No. It cannot. So this one has no solution. Now, here's the deal with this. Y'all listen carefully. If you solve these following the flip the symbol, change the sign, and or, you're going to get the correct answers. It's not like the equations. If you set the equation up and split it into 2, you're going to get 2 incorrect answers. Billy? 2 incorrect answers on equations. If you did an or problem with the first one and an and problem with the second one, guess what's going to happen when you shade the 2 or problems in the first equation? Inequality. In this inequality, if you split it into an or and shade them both, you're going to shade the whole number line. Guess what's going to happen if you treat this one as an intersection problem? You're not going to have any intersection. So it's okay. You'll see that if you split these up, that you'll get no solutions and all real numbers for those. All right. How would you do this? We're not going to work this because we are running short on time. How would you do this? Would it be an and or an or problem? Less than, and. Greater, or. This is less than or equal to, so it would be an and problem. Now, what's different about this one is, in both cases, look what happens. Right here, when you divide by negative 3, you have to flip the symbol. When you divide by negative 3, you have to flip the symbol. Okay? It's an and problem, so when we're graphing this, we're going to look for intersection, and so it would look like this. And if you're confused about this and you're watching the video at home tonight, you can definitely pause this and have a look at how it works. But what about this one? Would this be an and problem or an or problem?
Neither.
Neither. Why is it neither?
It's not absolute.
Because it's not an absolute value. So this is the tricky part on the next test. I do everything I can to try to keep students from not doing this, even telling you, promising you, betting you, daring you that you will do it. Someone will do it. I've never been successful at keeping someone from not splitting this into an or problem after I show you this skill. What problems get split into 2? Only absolute values. Okay, this is not an and or an or problem, so we're not going to break it up. We just divide by 2, subtract 3, and divide by 2. All right, that's actually my college algebra assignment on this lesson. There's one thing that you need to remember, and it's not covered explicitly in any of the examples. Y'all stop putting away and listen to me carefully. Before you can split it into 2 different inequalities, and or, you have to make sure that the absolute value symbol is by itself first. So you may have to subtract something from both sides, or add something from both sides, or divide something from both sides like we did last night's homework before you can split it into 2 inequalities. Okay, so keep that in mind. All right? You guys have a great weekend
Where's the homework?
and make wise choices.